and welcome to the February 2026 feature program for the Madison DX Club. I'd like to turn it over to Bob, our program chairman, to introduce tonight's speaker. Bob, take it away.
Yeah, thanks. Well, first of all, I always am delighted to see DX stations joining us. So I just want to thank DG6MS and DB9LG from Germany that have joined us tonight, and also J35 X-Ray. So good to have you. Thanks for joining us. We have a great speaker today. Carl's been with us many times. We always have a nice turnout for Carl. He gives a really super duper presentations, and when we put him on our YouTube channel, he gets literally thousands of views. So Carl, so happy to hear you and to have you with us again. And please tell us what all the good news is going to be as the cycle begins to wind down.
Okay, very good, Bob. As in life, there's going to be good news and bad news, so whatever. But hello to everyone. I see a lot of familiar calls, and hello to all you guys. And I don't know if there are any women here, but hello to you too, if so. I'm Carl, K9LA in Fort Wayne, Indiana. And I want to talk about cycle 25 and a little bit more stuff here. So let me see if I can share my screen. It looks like I can. Okay, share. Now let me get it full screen. There we go. It's full screen for me, so I'll wait a little bit for you guys.
Looks good.
All right. Again, there's my email if you have any questions after the meeting's over. Of course, after my presentation, I'll welcome any questions, and there's the website, which one of these days I'm going to update it. But, oh well, it's another issue. Oh, let's go here. Here's the agenda. Well, no, it skipped a slide here. Okay. What I just want to say is I'm going to talk about propagation. If you'd like more in-depth info on the sun and solar issues, here's some gentleman and a lady who I recommend. Dr. Scott McIntosh. He is gives regular updates on the Front Range 6 meter group, and his presentations are at that URL. The last one was, I think, January 15th. He gave an update. The Space Weather Woman, Dr. Tamitha, there's her YouTube channel. She's got lots of solar stuff on there too. And a Dr. David Hathaway. He's retired from the Marshall Space Flight Center and NASA Ames Research Center. He's got a nice, about 90-page little document on solar cycles. It has a lot of information on solar cycles. Not too much on propagation, but if you're interested in solar cycles, go take a look at that. It's in the in that URL there. You may be familiar with Dr. Tony Phillips. He does the spaceweather.com. And of course, there are a lot of websites with space weather data. There's the Space Weather Prediction Center, VE3N, Solar Ham, N0NBH's data, which shows up in a lot of places, like, for example, on QRZ.com. And of course, there are many more. But there's some stuff there if you want to go pursue solar issues and all that. So we're going to talk about a very quick update on cycle 25. Then I'll get into propagation on the higher HF bands, on the lower HF bands, and then on the middle bands. And I'll explain why I divided that up into the three categories of bands. Then do some information on a year of space weather data. It's kind of interesting. I kind of got interested in that because of the UK 6 meter group. So we'll see. Here's cycle 25 update. And there's the latest data. Cycle 25 is the thick red line. Cycle 24, the smallest in our lifetimes, the fourth smallest in recorded history, is green. And the blue is cycle 23, which if you could take an average of all 24 cycles, cycle 23 had a maximum about very close to the average of the 24 cycles. So as you can see, cycle 25 did not make it up to an average cycle. And it looks like it's in its decline right now. There's been lots of talk about a second peak, but I believe that's a very low possibility. And there's two reasons for that. The first reason is that only 8 cycles of the 24 have had double peaks. And I've never found a definition of what 2 peaks means. To me, it means that there are 2 maximums, and there's a very noticeable dip in between. So 8 of the 24 have shown that. The second reason that there's a low probability of a second peak is usually because the second peak occurs around 5 years after solar minimum. And you can see, just looking at the horizontal axis, that we're right now 5.5 years past solar minimum, which occurred in December 2019. And as of now, there's no hint of a second peak, but never say never. So let's wait and see what happens. Okay, propagation on the HF bands. Okay, the higher HF bands, which are 15, how come the, how do I get, oh, there we go. 15, 12, 10, and 6 meters. The higher bands, these bands need sufficient F2 region ionization. And that's because of extreme ultraviolet UV radiation from the sun. Ionospheric absorption, which adds loss to your signal, is not an issue, as absorption is inversely proportional to the square of the frequency. So the higher in frequency, the less the ionospheric absorption. So what really drives these bands, 15, 12, 10, and 6, is the F2 region being sufficiently ionized to refract our signals back to ground. Here's some guidelines for when these bands are best. It's when the long-term solar flux, long-term kind of means more than just a couple days or a couple weeks, but trending toward the smooth value, which is heavily average. So for 15 meters, we need a long-term solar flux of about 85. And as you see, we go up in frequency, we need more and more solar flux, which is really more and more extreme ultraviolet radiation for the other bands. For 10 meters, we need greater than about 100. And for 6 meters, greater than 200. Now, those 2 bottom bands, 10 and 6, of course, that usually occurs around solar maximum. So when will cycle 25 decrease to these values? Well, what we can do is look at the, oops, what happened? There we go. Look at the NOAA prediction. Well, shoot, I should have put the URL on there, and I'll do that before I send this presentation to you, Bob. But that's solar flux prediction for the rest of cycle 25. And remember, 6 meters, we needed a solar flux of about at least 200. Well, we're not going to get that. So all we can really hope for are some F2 openings due to short-term enhancements, and also hope for sporadic E in the summer. Now, for 10 meters, we need a solar flux of about 100. So if you look at where does 100 intersect, and that looks like at the end of 2027. So we may have good propagation on 10 meters for for 2 more years, a little bit less. And of course, it depends on how fast cycle 25 declines compared to this prediction here. For 15 meters, well, we don't need as much F2 region ionization as on 10 meters. So 15 meters, remember, went out to equivalent to about long-term solar flux of about 85. And that takes us out to about the end of 2028. So we still have some time left on the higher bands. If you're working on DXCC or worked all states or worked all zones or whatever, be a good time to get on the bands before we get, before cycle 25 is too low and we have to wait for a lot of years and hope that cycle 26 will be big enough. Okay, here's some other issues on the higher bands. One is during the decline of a solar cycle, we must accept the bad geomagnetic storms due to coronal holes with the good, still enough ionization for these bands. And I'm going to go to the next slide real quick because it kind of shows it. Here's a plot of the daily AP index, which is derived from the average of the 8 3-hour K indices. Here's AP versus the 10-meter solar flux for cycle 24. The solar flux is in blue and the AP index is in red. And you can see at the first peak of cycle 24, the AP index peaked. But there was a second peak, and during the decline of cycle 24, you can see the AP index really went up even higher. So what we conclude is the AP values during the decline of a solar cycle are greater than around solar maximum, which is mostly due to CMEs, coronal mass ejections. This is not good for any of the bands, and well, that's the way it goes. So we go back to that previous slide. The smallest antennas are on 15 and 10 meters, and of course 6 meters. So that makes it simple for some people. And also you got to remember FT8 offers an advantage over sideband and CW. FT8 and all the other digital modes gain this advantage by using a very narrow decode bandwidth. In other words, the signal to noise ratio in the decode bandwidth, like for FT8, that's probably around 50 hertz or so. The signal to noise ratio in that 50 hertz bandwidth, which lets in a lot less noise than 2500 hertz, is around 0 dB. So that all makes sense. And FT8 really helps if you're running modest power and, maybe 100 watts or even QRP. And you have modest antennas, maybe a dipole or a vertical or something like that, nothing big on a nice high tower. And there on the right, there's a little sketch of a solar cycle, and it shows that solar flares and CMEs are most prominent at solar maximum. Of course, they can occur anytime. And coronal holes, which are worse than CMEs in terms of causing geomagnetic field activity, occur on the decline of a solar cycle. So we're going to have to just put up with the coronal holes and make the best of it. There's that. We also already covered that. Another issue on the higher bands is you got to remember that the daytime MUFs, maximum usable frequencies, in the northern hemisphere are highest in the fall and winter months, and that's what that plot does. That's from K9LA to Great Britain. It's at 1500 UTC. That's certainly daytime. And the data comes from VOACAP. And the 3 different curves are different levels of a solar cycle. Blue is a small solar cycle. Orange is pretty much an average solar cycle, which kind of where we are now. And green is a big solar cycle. What's interesting is around the summer months, The solar cycle doesn't matter too much. The MUFs on a path from K9LA to G are around 20 megahertz. What you can see is that when you hit the fall and winter months, the bigger the cycle, the higher the MUFs. So just remember that we're going to have to go through this summer. That's good because we'll get nice warm weather and hopefully all our snow will melt by then. And all I can say is sporadic E can help in the summer if it occurs. And of course, that's a biggie for the IARU contest and also field day. Sporadic E is a big help on those bands or those in those contests. Now, always watch for a moderate spike in the K index that can cause an enhanced F2 region, mostly at middle and lower latitudes. And here's some examples. The top example is the 2018 California QSO party. On the left is the MUFs over the Boulder ionosonde, assuming it's the midpoint of a 3,000 kilometer path. Up to the days of the contest, the MUF was around 20, but then the K index spiked up to 5 right on the towards the end of Sunday of the contest, and look what happened to the to the MUF once it went up to 30 megahertz and 10 meters was open, and I worked W6s. Now, don't think this happens all the time. So here, that's what the bottom two plots are. It's the same days. The one on the left is the MUF at the ionosonde in Peru. You can see when the K index spiked up on late August 5th, the MUF decreased. Well, okay, let's go over to the Eglin data on the right. And when the K index went up to 5 on late on the 5th, or 5 and 6, the MUF had a nice increase. So it's still just worth to see what's going on if you see a moderate spike in the K index. Hi, links. Okay, here's something I kind of tend to look at every morning. This comes from that URL. KC2G puts it together. And this is at 11:15 UTC, which is 6:15 a.m. EST, Eastern Standard Time. And you can see the MUFs, that's what those yellow dots are, ionosonde data, are in the low 30s. So that's kind of interesting. So what that tells me is that more than likely the MUFs over North America later in the day are going to be up in the low 30s. And here it is. This is at 18:15, which is 1:15 p.m. EST. So you can see North America's in daylight. The ionosondes are saying, yeah, MUF is in the low 30s. So that's a good indication of what may happen later in the day if you look at what's happening at Europe early in the morning. Of course, if a CME or a coronal hole comes along, that could throw this out of, really throw a wrench into the data. It could be that the MUS would be high early in the morning over for us, but then later in the day, if that CME and coronal hole hit, then the MUFs could be lower. So that didn't translate too good, but it's a good thing to look at. Notice that there are a lot of ionosondes over in Europe that report data publicly. Notice that over in North America, there's only 3 right now. The 33 there is Idaho National Labs. The 34 is Austin, Texas. And the 34 on the East Coast is Millstone Hill in Massachusetts. Unfortunately, those ionosondes may even be going non-public, not online, offered to the public, which means we're not going to be able to use these maps. We'll see what happens. Okay, now let's move to propagation on the lower bands, 160, 80, and 60. Yeah, we got to make sure we include 60 nowadays since we have more privileges. You got to remember the continuous the band that we can go anywhere is 9 and something watts ERP. So if you got a 3 dB gain antenna, you can only run 4.5 watts. So you gotta watch that. Now these bands need the lowest ionospheric absorption to be heard or decoded. The MUF is usually high enough so we don't have to worry what the solar flux is or anything like that, how high it is. Of course, atmospheric noise, which is discharges from lightning discharges from thunderstorms, is greatest on these bands, and also man-made noise is greatest on these bands. Now, the good news is we have more electronic devices to keep us connected. Of course, the bad news is there's more noise nowadays to hinder us because of this. And on the right is a nice chart. The dotted blue line is the old International Telecommunications Union data from the early 1970s. And you can see on 160, the noise is about minus 80 dBm. Now, if we go to the solid blue, that's new data around 2019. And the articles in IEEE transactions on electromagnetic compatibility. And what that tells us is the blue is residential environment, that the noise on 160 could be about 10 dB higher. So that's not good. If you're in a residential area, that's the orange data, it's a little bit better. And if you're in a quiet rural, you'd probably have maybe a dB or two more on 160 nowadays than back in the 70s. So kind of depends where you live, and it also says that it would be very advantageous to have some receive antennas, low noise receive antennas to help, especially nowadays. Thank goodness both atmospheric noise and man-made noise, they decrease as you increase in frequency. So it only really affects these lower bands too, mostly. Now, there's some other issues on the lower band. As I mentioned, noise floor is higher nowadays. And here's something I'm wrestling with. Signal strength on 160 just don't appear to be as high as in earlier years. Now, this may just be my biased observation because I got on 160 and seriously in 95, 96 solar minimum. And of course, anything I worked on 160 was new. So that may have biased me to just think that that was better times than nowadays, but I'm not sure about that. The question I have is there additional ionospheric absorption occurring nowadays? And it comes from, does the CO2 that we're dumping into the atmosphere causing more absorptions down at D region altitudes? Don't know what to say about that, but yeah, we still gotta just get on there and work whatever we can. Of course, the lower bands require the largest antennas. There's a dipole on 160 is 260 feet long, which that could be a problem for a lot of people. And again, FT8 offers an advantage over SSB and CW. How about propagation on 40, 30, 20, and 17 meters? Those are the middle bands. And you remember the higher bands, ionization was important, absorption wasn't. On the lower bands, absorption was most important and ionization wasn't. So that's why these middle bands are kind of called the middle bands. It's because they don't need as much ionization as the higher HF bands. And these bands can tolerate more ionospheric absorption than the lower bands. Generally, they're good throughout a solar cycle. Antennas are of medium size, and again, FT8 offers an advantage. And I just pulled that data from Clublog today. It's for a week period, I believe, and you can see that 62% of the QSOs reported to Clublog are FT8. And of course, that's equal to or pretty close to all the other modes, CW sideband, FT4 really summed together. So amateur radio is turning to digital, that's for sure. Okay, let's go look at a year of space weather data. I've kind of given my best guesses on what the bands are going to do during 2026, but let's take a little bit larger view of stuff. And it comes from the December 5th, 2025 solar report from the ARRL. And there's the quote from the solar report: the significant increase in solar activity since the beginning of December has finally confirmed the original assumption that the current 25th 11-year solar cycle will have two peaks. The first occurred last October. That's when cycle 25 peaked, October 2024. We saw that in the cycle 25 update. The first occurred in last October, while we have been eagerly awaiting the second this year, especially in the fall. Well, to me, and I am aware that there were several others, that this was a puzzling statement for the reasons on slide 5. So let's take a year's worth of space weather data and dig a little bit deeper into it, see what happened. So here's what used to be called the shortwave listeners website or whatever, but now it's www.solen.info/solar. What it is it's a year's worth of data of 10.7 centimeter solar flux, the daily sunspot number, and the AP index, the daily AP index, P signifying it's a planetary value. In other words, it's kind of an average of a bunch of observation stations around the world. The red is the sunspot number. The 10.7 centimeter solar flux is black. Then they also have some averages in there. The 27-day average of the the sunspot number, and the 81-day average of the 10.7 centimeter solar flux. But take a look at what happens. What's very obvious in that plot is the sun's mid-latitude 27-day solar rotation period for active regions on the sun. That's what those black and red spikes are. So every month or so, we're going to see the solar flux and the sunspot number spike up. Maybe the AP index at some of those peaks also. So do these spikes in solar flux and sunspots help or hinder? And I mentioned the UK 6 meter group, and there was a gentleman on there that said that there was a solar flare in the 6 meter band open. And so I took a deeper look at that, and I don't think so. I think it was sporadic because it was during the summer. Okay, I annotated the early December rise in the solar flux and the sunspot number that came from that ARRL solar report. But I decided to look at the January data, January of this month. It didn't peak as high, but it was up there. It certainly was a nice peak. So what I took a look at was the MUF over the Idaho National Labs ionosonde during January 2026. Now this, again, this assumes the ionosonde is at the midpoint of a 3,000 kilometer path. If the path would be shorter, the MUF would be lower because there's just not enough ionization to refract the higher elevation angle signals. And there's what the MUF look like through the whole day. You can see there's some high spots, there's some low spots, and let's look at the solar flux and what it did. But first, we're going to talk about what causes the F2 region MUF to vary. Well, there are three things. There's solar radiation at EUV wavelengths that can cause the F2 region MUF to vary. Geomagnetic field activity, as indicated by the 3-hour K index and the daily A index, could cause the MUF to vary. In general, it causes it to go down, the MUF to go down. And the third one is events in the lower atmosphere can couple up to the F2 region. We can measure these events, but we can't predict them yet, nor do we have any real parameters to define what's happening. You know, for example, solar radiation, we've got sunspots, we've got 10.7 centimeter solar flux, we've got EUV. Those are three good parameters to give us an idea what the F2 region is doing. For geomagnetic field activity, the parameters of you can pretty much gain a lot of information and understanding by just using the 3-hour K index and the daily A index. But we don't have any parameters for the events in the lower atmosphere coupling up to the F2 region. When we're talking about events for, hurricanes, tornadoes, thunderstorms, even earthquakes, we can see a signature of them in the ionosphere, although it's pretty much just around the zenith of, straight above the occurrence, the earthquake. And there was a great volcanic reaction a couple of years ago that caused some pretty significant variation in the F2 region, but it was pretty much restricted to around where the volcano was. But we need to understand this more before we can predict what's causing this stuff to happen. Okay, let's go look at the 10.7 solar meter flux during January, and here's a plot of it. Just the 31 days, and you can see that the lowest solar flux occurred on January 9th through 13th. We had that peak in the solar flux on the 18th. Then we had a smaller second peak on January 22nd. So let's put together the MUF and the solar flux chart and see what happened. So there's the MUF in blue. On the left, there's the lowest solar flux on the 9th through the 13th. There's the first peak of the solar flux on the 18th, and there's the second peak on the looks like 22nd. Yeah, that's right. So did the low solar flux cause the decrease in MUFs on the 12th through the 16th? Maybe not. I think we're going to have to take a look at the AP index later. Did the two peaks in solar flux cause enhanced MUFs? Not much, if any. It's kind of hard to tell what happens. So it kind of leads me to believe that that peak in solar flux really didn't help. Maybe it didn't even hinder it. It's something else that's going on. So, like I said, we're going to look at AP, and here it is. During January, the orange columns are the AP index. AP is a linear index. It goes from 0 to 400. There's a little chart there on the right that convert between K and A. And I've also indicated the equivalent K indices in black there. There was a coronal hole arrived at Earth on January 10th, and you can see that the K index went up to 4. The K index is logarithmic, so it only goes from 0 to 9. And then there was an X 1.9 solar flare. That's a big solar flare, and a CME on January 18th. As you can see, nothing happened on the 18th yet to the geomagnetic field. The CME took about a day to arrive, a little bit over a day. It arrived late on January 19th, and you can see that's what caused the AP and the K indices to rise. So let's put the MUF and the AP data together and see what that happens. There's the MUF in blue again. Earlier in the month, the coronal hole arrived on the 10th. It's hard to tell if anything really happened. Maybe the coronal hole caused the decreased MUFs from January 12 to 16. Solar flare and a CME on the 18th, but it doesn't look like anything happened. The CME did arrive a little bit later, and it may have affected the stuff on the MUF on 20. You can see that the MUF was only narrowly high throughout the day, not like the other days where there's the whole day had a lot of MUFs up there. So again, like what I said, my guess is the coronal hole caused the decreased MUFs from January 12 to 16th. The CME arrival may have caused the short duration MUF decrease on the 20th. It's hard to tell. So that spike in solar flux appears to have hindered propagation from a coronal hole and a CME, and that's kind of what the data suggests. Again, this is just a look at one month and one CME and one solar flare. So who knows, in one coronal hole. If I looked at more and more, maybe some other conclusions would come out of it. So here's a summary. Cycle 25 appears to be in its decline, but never say never. So it would be really interesting if we did have a second peak this late. But I'm not going to bet on that. Like I mentioned earlier, take advantage of the higher HF bands right now, and always watch for an F2 region enhancement when there's a moderate spike in the K index, and especially keep your eye on 6 meters. Middle bands should be good throughout 2026, just like the higher band should be pretty good through 2026. Lower HF band should be improving, but factors other than propagation, mostly noise, likely to hinder these bands. If you think about it, the coronal holes are most prevalent during the decline of a cycle. The CMEs and solar flares are most dominant at solar max. So what that says is the quietest period during a solar cycle was generally solar min and the initial rise of a solar cycle. Hopefully a lot of us will be around for that. We'll see. CMEs and coronal holes play an important role in generally degrading the F2 region, except for the enhancements, as I mentioned before. And something else that's really interesting that I'm finding very interesting is keep your eye on the James Webb Space Telescope. It has really thrown a wrench into our understanding or lack thereof of the universe. All kinds of interesting stuff. You got to, apply some common sense to some of the stuff you see on the web, but whatever. So, Bob, that's all I had. If there are any questions, I can certainly try and answer them. And like I said, I'm going to send a PDF of this if you'd like to do anything you want with it.
Thanks, Carl. Any questions for Carl? Scott, I know you had a question before the program began.
Hi, Carl, Scott.
Thanks, Scott.
I do a lot of contesting this past year on 10 meters, single band,
Yeah.
mostly because I like to sleep. And
Yep.
it, as we go through the cycle, it looks like I need to, if I wanted to keep doing that, I would want to go down the bands a little bit more. So the first question is, it's like, how soon should I go to 15? It sounds like when I get to 85, whatever that number was. And then the other question is, when does 80 meters start to work out to be a good band to do contesting on?
Oh, well, it depends on how long you want to keep your butt in a chair, really.
Right. Yeah, no, I know that.
Yeah. I don't think you'll have to worry about 10 meters too much this year. I think cycle 25 will still be big enough to give us some very good results as long as they're in a coronal hole or something that lowers the MUF. So I wouldn't worry about that. As for 80 meters, it should be getting slightly better because the decline says there's lower absorption. But again, I think the noises may maybe overwhelm that improvement in absorption. But again, I think the winter months for the lower bands are when you should be on, and you got to keep your butt in a chair, and 80 meters should be okay. That's a good question that I'm wrestling with. I need 3 zones on 80 meters to complete my 5-band worked all zones. And as of right now, I'm holding out to try and work them on CW. But maybe
Yeah.
someday I may have to go to FT8 because of the advantage there. And of course, it depends on how good my antennas here are on 80 meters and also, of course, on 160. So
Right.
You gotta have some receive antennas for 80 meters and 160 and good transmit antennas. And you'll be able to work a lot of stuff on them, I think, especially during CQ Worldwide CW, ARRL DXCW, and CQ 160 which is CQ 160 CW.
I've got good transmitting antennas on 80, but I don't have receiving antennas. So that's something I should probably look at.
That would help. And how much property you got?
I have 2 acres, so I can,
okay.
I have some stuff I can work with. I've got a 67-foot full-size vertical on 80 with 60-foot verticals underneath it.
Mhm.
And that works really well.
Oh, yeah.
And I'm also in nowhere, Vermont. So I have like very rural, low noise situation, not like in an urban area at all. So that helps a lot.
Yeah, we're in a quiet rural environment on 2 acres, and I had a 200-foot bog for 160, beverage on ground. It worked great. And it was decidedly an advantage. It was the K9LA reversible bog, so you could switch it in the shack from, I had it northeast, southwest, and it worked pretty good. And of course, 200 foot, that's kind of easy to put down when you're on 2 acres.
Right.
So,
whatever. And I have nice neighbors. I have nice neighbors too. So
that helps too. Yeah, that helps.
Thanks, Carl.
Okay.
I have a question, Carl. This is Jim, K9YC.
Hey, Jim, how you doing?
Good. Always great to hear you and see you.
Yeah. Hey, do you any thoughts about moving back to 9LA?
Oh no, no,
Okay.
no way.
Okay.
We moved into this redwood forest and thought we died and got to heaven.
Oh, okay.
It's just lovely out here.
Oh, yeah.
Except for propagation to Europe.
Yep, there you go.
But my question is about 6-meter propagation when we're going to Japan.
Yep.
It gets bonkers. We tend to have long openings, as you might suspect. They move around. Am I looking at multi-hop sporadic E, or or is there something else going on?
Well, there could be something going on. Sporadic E, of course, is, I think we probably understand it the most, even though we don't have the exact reasons why sporadic E happens. We can't predict when it's going to happen, but we've seen enough of it that, yeah, sporadic E to Japan shouldn't be too much of a problem. F2 region, I think you'll have to get more ionization in the F2 region than where we are right now in cycle 25. But again, the F2 region is very dynamic and it can surprise us. How high is your 6-meter antenna?
It's about 120 feet. And I'm working into a dense redwood forest, so there's a fair amount of absorption. But what I'm seeing is these openings to JA do not appear to be tied to solar cycle.
Okay.
So sporadic E does make sense, and it's kind of what I've assumed.
So are they mostly in the summertime then?
I'd have to think about that.
Okay.
Yes, I think you're right. I think yes.
Yeah, so that's probably sporadic. And your antenna, I didn't, well, hold on here. Let me look. Gary, W9XT, you on here?
Magic used to do that same thing if I would pet him, I'd pet him.
No, I guess he's not. He had a 6-meter antenna up at, I don't know, 50, 60 feet. And some of his people in his area were working JA and he couldn't. And then he put it down lower at like 25 feet and he could work JA then on 6 meters. And of course, what happens with the antenna is too high, you're going to have nulls in the pattern down at probably important elevation angles.
Well,
so just something to think about.
Yeah, well, my situation is quite different.
Okay.
I'm at 2,000 feet, and the ocean is about maybe 6-7 miles away.
Mm-hmm.
I'm just down the road from K6XX. I shoot over him to go to Europe.
Oh, geez.
He's about 700 feet above me. The other question I had was respect to, well, my experience has been that 160 propagation from here to Europe is best at low points of the solar cycle.
Mm-hmm.
I was able in the last minima to run FT8 on 160, legal limit.
Yep.
And pick up, maybe 25 new countries that I was not able to do on CW. I haven't heard CW from Europe here in about 5 years.
Yeah.
And that's all noise.
Yep. Yeah, there's, you can't do anything about the auroral zone. And it's amazing how much that degrades the lower bands. I remember KL7RA, Rick, you remember him? Rich?
Oh, yeah, sure.
Yeah, I remember when he moved from, did he move from Fairbanks or down to the Kenai Peninsula? He said it was a completely different world because he got out from under the auroral oval. So, of course, that's in a way when you're going to Europe.
Yes.
And the only thing you can hope for is maybe the Earth's magnetic field will flip and then the auroral oval will be over Hawaii or something.
Now, the difference is really obvious because I do very well into Europe.
Yeah.
Or I'm not Europe, I mean into Africa, and not so well into Europe.
Yep. Yeah. Not much you can do about the auroral oval. So, except hope for, solar men and the rise of a solar cycle appear to be when it's the quietest. So pay attention to that when that comes around here in a couple of years.
Right. Okay, great. Thank you very much.
Sure.
Any other questions for Carl?
Yeah, one real quick, Wolf and N7CW. Carl, real quick,
Yep.
am I allowed to steal your slide content for a kind of like local presentation? I run a small company radio club and
Yeah.
always
Yeah, I've worked you a bunch of times and recently, in fact, I think. Why don't you send me your email address and I'll send it to you.
Great, thanks, will do.
Yeah, K9LA@ARRL.net should work.
Yes, I'll figure that out. Thanks again.
Yep.
Any final questions for Carl? Once again, Carl, this was a fantastic presentation. I love going back literally over the years, the presentations you've had, and my recollection is your predictions have been pretty consistent and pretty spot on. So, and I think it's more than luck. So we're very fortunate to have you share your experience and wisdom with us. So
Well,
thanks
thank
a
you.
lot.
The secret is to make predictions that are very general, so they'll come true regardless of what happens. Yeah.
And,
Oh, well.
and remind people when you're right.
Yeah.
Okay, with that, I'll wish everyone a good evening. Thanks for joining us tonight, and we'll have this up on our YouTube channel in
Okay.
a day or so.
Sounds good.
All right. Good night, everyone.
Okay. Bye-bye.